I don't know if anybody would be interested in watching me take this apart, but as I'm going to take it apart anyway, I thought I might as well video it. It's a Triton Madrid 2 shower, so a cold water to hot water shower unit. Strange fault really. A couple of days ago, I leave it on pretty much there, 5. Get in the shower every day, switch it full power, have a shower, no problem. In the deep dark depths of winter I suppose I might turn it up a fraction, but generally speaking it's about here. Anyway, a couple of days ago, turn it on, it's cold. I think, oh, shower's broken. I turn it up, not quite so cold. Turn it up some more, not quite so cold. And I get to about here and I think, well, I can manage, I can have a shower. So for a couple of days I've had a shower like that, and then I thought, this is just stupid. I'll replace it. Now you can't buy this one anymore because it's old, but ironically you can buy almost an identical one. All they seem to have changed is the knobs and switches, but everything else is the same, which is fantastic because you can take this one off the wall. The new one, all the plumbing points, all the electrical points, they're all identical, so really easy job to change. Right, let's have a look at it. Now, before I say any more, never go anywhere near something like this with any kind of power anywhere, because this is a 9.5 kilowatt heater. That's 9,500 watts, which means it can draw roughly 40 amps, which means that you need a very heavy duty cable to power this thing. And if you were to be near it when it was live, that's going to be a really bad day, as in probably ending all your days. So never go near one of these when there's any possibility that anything is live or connected in any way, because they are seriously up there in terms of power. In fact, I think in the UK the highest electric vehicle charger you can get is 7.5 kilowatts, which is 2 kilowatts less than this. I could be wrong, but I think it's 7.5. Right, okay, never mind all that fussing about. Let's have a quick look at it. Right, the top just comes off. It's held on by 4 screws, so it's pretty easy. You just, and obviously I've had to take this off once because I had to take the top off to get it off the wall. Ooh, that was tight. Come on, you can do it. Seems very noisy, this screwdriver. Right, and that comes off. And that is what you're faced with. Now the first thing I noticed, which I don't think has got anything to do with the fault, is that this shouldn't be doing that. And down here were 2 pieces of broken metal. They're not here at the moment, but there's a spring. It's a sort of that shape, and it sits like that. It should sit in there, and this is square there, square there, square there, and square there. So as you turn it, you have to force it past the spring, so it sort of goes clunk, 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 clunk. But of course it doesn't, because it just spins freely now because the spring was broken. But obviously that wouldn't have affected the way that the thing could heat, because you could still put it in the right position. So, and if you listen, you can hear a micro switch. Another micro switch. So just that one there, that one there. So I presume that's our 2 heats. And there is another one right at the bottom, which is why when you put this in, it's offset there. So when you put this in, you can only put it in can't remember which way around it is, but there it is. It drops down because there's only one place it will actually start from, and that's there. And I think when it's there, that might have been cold and off. So in other words, cold, warm, hot, off. And I think when that's there, you put the switch, the cover on, that becomes the off position. Right. What should we start with? Let's start with water. That's water out. So this is what gets your water hot. So obviously this was not doing its job. And then the hot water comes out here. In case something leaks, it's got a little overflow, and it looks like something may have been leaking because this looks a little bit crusty. The water goes in here. It's just a compression fitting, and you just put 15mm water pipe in Britain onto there. Water comes in. So this is water in, all the way up to there, into there, get hot, so presumably it goes round here a bit, come out, hot water. So the hot water side, piece of cake. This varies the temperature, but it doesn't vary the temperature by changing anything electrical. The electrics is either on or it's off, or I'm assuming there is a point where it's on the lukewarm setting, so there might be something affecting a lukewarm setting. And of course it's possible that that's what's gone wrong with this, and that it was jammed on the lukewarm setting. But I wasn't going to start taking this apart and fiddling with it. I'll get a new one. This is a lot safer option. Right, so the water comes in here. This valve has got to obviously turn on to allow the water to come in. So although the water pressure is here, it can't come on until this is turned on. And at the moment it's off, so we turn it 90 degrees, it's on. I presume this opens this valve, water goes in here, across here, gets hot, comes out. This adjusts the flow. So as you turn it and reduce the flow, the water going through here goes slower, gets hotter, comes out hotter, but you get a lot less water. Turn it the other way, it gets colder, you get a much better flow through here, but of course it's colder because it's flowing faster. So I think this thing only ever heats at 2 heat settings, which is why the front has got turn on, which is cold. I don't know why they didn't put on, but it's cold. Low heat, high heat, stop. So it's possible when it wouldn't work properly it was stuck on that setting. I don't think it was, because it just seemed too cool even for that, because I've not often put it on that setting, but I've got a feeling that if I had had it about there on the full setting, it had gone from, in previous times, being perfectly warm and hot, or hot enough for me, it had gone to being cold. Now I've got a feeling that when if I ever turn this down to there, which I'm not even sure I did, but if I ever did, I don't think it went cold. I think it still was reasonably warm. It just wasn't very warm. And then of course you'd go there and it'd be cold. So I doubt the loss of heat was because it somehow thought it was here and not there. I don't think that was it. And like I say, the only way I could get a reasonable heat here was to turn this almost to full on. Right, so as I say, that valve opens, so you turn this, power on, where did I say? Yeah, that's it. So turn that, power on, this opens, water flows through, gets hot, it all works. Here's our earthing system. It's got to be earthed. It's absolutely vital that it's earthed, because if something shorts out in here, you hope it will short to earth, and that will blow the fuse and protect everybody. There's our live, brown for live in Europe, blue for neutral in Europe. Nice, really nice big beefy cables. I'm not sure what size that is, but let's have a look and see if we can... Well, that ain't going to undo it, is it? So they're obviously tight. Let's turn it round, try a different setting. Whoa, still way too tight. So there's one easy way of beating that. Will this fit in there? Yep, oh, pulled it right out. Wins every time, this one. You can see, nice big beefy cable. Nice big beefy cable. And that neutral runs across and becomes the neutral over on here. But it is, I don't know what size that is, but it's, I don't know, perhaps 5mm square. I think, yeah, I mean, I think half of that would be about a 2.5, so that could well be 5mm. So that's a pretty beefy cable. Right, let's pull a few more bits and bobs off of here, shall we? I've got a feeling I can't get down there. Let's find a screwdriver, because that won't go down there. But if I get down there, and down there, right, let's pull those leads off, because we don't care about those at the moment. As far as I can tell, this doesn't contain anything like capacitors, so we don't have to worry too much about any charge that might build up. Haven't seen any. Then that just comes out, and presumably that's still working okay. It would be interesting actually to find out, because I could possibly connect that up to a hose pipe and have an electrical switch and use it to turn the water on and off in the garden, but probably never get round to doing it, but you could. And this, like I say, it must be some sort of flow regulator, so don't know if we'll be able to get this out. I might have to take several bits out at once. Yeah, that hasn't really... Oh, where's it? Yeah, it's sort of jammed on there, I think. Come on, get out of the way, you. Yeah. But that's not gonna... Yeah, it's tight in there. We might have to remove some other bits to do that. So let's shift this. See if that will give us a bit more leeway. I could be doing these with a screwdriver, couldn't I? Because that's... Oh, there's only that one there. So that's another one out. Right, that's that out. So does that give me a bit more movement? Oh yeah, oh look at that, look. So that would lift out now. And does that? Yeah, that's just push on. So, and it's got water in it. So that presumably... Oh, well, it's damaged in there. Oh no, it's supposed to be like that, I think. Or is it? It's very strange the way that O-ring is in there. No, that can't be right, can it? Let's have a look at that. That must have been like that since they assembled it. Surely it's not meant to be... Look at that. Or was it that shape from new, do you think? That looks to me like that's just been buckled. Any different there? No, I don't think so. So I think that should have just been a plain O-ring and it's been mullered when it was assembled. Oh well, never mind. Right, so, more water falling out. So, that's our flow, variable flow rate. This is a little neon, so this tells us that we've got power. And this, I assume, is full of micro switches, or at least a couple. Let's pull this out. So let's see what that does. Well, apart from attaching a lot of wires. Right, let's have a look. So we've got a little bit there that... Oh, that's interesting. So that would move, but it's not moving at the moment. Not quite sure what that bit does then. It doesn't seem to be touching anything. But it looks like we've got two different micro switches there and one at the back. So I was right, there's 3 micro switches in there. That's handy. I can always use micro switches, and these are usually quite robust. So pull that off. Let's have a look at these. Let's come off. Let's get something to... Oh no, they don't. Oh, look at that. They're not pull on, push off. They've been... Well, I don't know what they've been. They've been spot welded on, haven't they? Oh, I didn't want those coming loose. Right, let's have a look. Let's get rid of these then. What else have we got? We've got one over here. Obviously I'm never going to put this back together again, so I don't care how it comes apart. What's rattling? Something. Oh, it's that bit there. So why? Oh, that works on the micro switches as well. So when does that? So the flow rate thing can... So that would fit in there. So is that like an emergency? Can that... No, I don't... How would that do that then? Because there's barely room. Oh, that is strange. That, how would that ever pop up high enough to hit that? And then, because when you go like that, you can listen. So if it was pushed up, it would hit the micro switches. But this... Oh, it can push up. Oh, right. So it must, that must be for the water flow, mustn't it? So when the water's coming in here, it's at water mains pressure, which I think is about £4 per square inch in the UK. And that must push this up and close those two micro switches, I suppose, to sort of say, yes, I've got water flow. If anyone's watching this who knows more about this, they can always correct me in the comments, but as very few people ever watch my videos, that's not likely to happen. Right, so we've got this to here, that to there. Right, so that's still stuck on there, so let's get that earth lead out of the way. Ugh, this thing's leaking water onto me again. So why is that then? Whoa, we're doing a good job of weighing all over my bench. So we're getting some water. So that's neutral, that's live. Oh, don't really know what these are, that's just the earth. So pull that off and get it out of the way. Don't know if I'm ever going to make use of any of these bits of wire, but still. And so that is the heating element. Does that come off? Oh, that comes off as well, doesn't it? Oh, I think we're going to have to cut this open, aren't we, and have a look inside. I can't imagine that we wouldn't want to do that. It's got a warning on it saying that you must never put this anywhere where it can freeze, which of course would be reasonable, because presumably if this was left with water in it and it froze, pop, that would be the end of it. So, what is this? Oh, I'm doing a good job of filling up my micro switch with water. Right, oh well, we'll leave that for now. So is that some kind of over temperature thing? We might have to look that up. That's 48C, 75C. Could that be a temperature? Yeah, it's almost got like a little spring on the back of it as well. That's strange. Oh well, I'll look that up later on the internet, see if we can find out what it is. I'm going to have to tidy up a little bit and come back. Right, I've tidied up a little bit and I've just noticed that I can almost get these side cutters, well they're not cutters, side cutters, they're end cutters. I can almost get these end cutters in here, and then if I left like that You can see it's lifting it up. Now I don't think that's going to work too well on the corners, but here on the straight it's working, and it might go round the corners, but I might have to go round. You can see it's going to be pretty tedious a little bit at a time, so I'll bring you back when I've got that all loose. Right, that's it, edge peeled back. I don't know if this flange comes apart, because you can see that it's peeled back and nothing's happening. So we'll get a little hammer and we'll try a little bit of a tap 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 tap. Oh! More water. Oh! So that's how they do it. We've got two elements. So it doesn't actually, yeah, because then cold comes in, gets hot, round and round and round and round here, goes right up to the very top, into there, through, out the bottom. Ah, so maybe I was wrong. Maybe that is exactly what's gone wrong. We've got a coolish setting and a hot setting, and maybe the coolish setting is one of these is on, and the hot setting is both of them is on. And to look at these, they're looking different, aren't they? So could it be one of these is dead and one of them isn't? But it's not easy to tell looking at this. So it looks like if you could just buy this piece, you could probably just fix your own heater. I mean, you wouldn't want to repair this, obviously, but if you could buy this whole thing, if it's anything like power tools, this would cost more than the entire heater would. So yes, I think I was right. I think what's happened is the only one still working was the weaker of the two, and I presume 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, count that, 7. So if we say this one did slightly more heating than that one did, I could be wrong, I often am, but let's take a guess and say this one does more heating than that one does. So this one packs up, so why does the thing still produce some hot water? Because it's still got this one working. Or vice versa, because it doesn't matter, does it? So now we know what the problem was. One of these was still working and one of them wasn't, and that's why I couldn't get a warm shower anymore. Oh well, I'm well pleased about that. So now I know, and that says on there, is that, I can't quite make it out, but it looks like S9.5B. So presumably that's just a reminder that this was a 9.5 kilowatt. But I guess if you could have bought just this unit though, it's looking like that was the only thing that was broken, and apart from the silly little spring that should have been on here that broke. I can't even show you it. It's shattered in about 3 pieces, so you could barely make out what it was. It took me a while to realise, and in fact it wasn't until I got the new one I could see, not the spring, but I could see roughly where the spring would have mounted, and that's when I realised, because I don't know, there it is, the spring mounts on that little plastic button sticking up there, and it, like I say, it's a sort of cross shape. It sort of looks a bit like that, and it goes round here and then it splits off and it sort of sits in there. But so yeah, I would have still needed that fixing, which I bet you can't buy. But yeah, I guess if you could buy these, you could just replace that. But I'm not sure it would ever be worth it. And I know for sure, absolutely for sure, that if I suggested to my wife that I take this apart, replace parts in it and then carry on showering, I'd have got a saucepan on the head. Right, well, I hope you've enjoyed this. I have. I'm absolutely gobsmacked about all the stuff that's inside here. I'm not sure if it's worth taking these parts apart. This doesn't look as if it comes apart any further than that, and I might have a read up about it and see how it works, because presumably it's just a coil and a plunger, and it lifts a plunger up and down so the water can either go through or it can't go through. So you could probably use that as a cut-off valve, like I say, to control water in the garden if I wanted to. Don't know, have a think about that, because I don't really enjoy playing around with mains powered stuff, because obviously it's dangerous. I've got a big pile of screws, so I shall save those. I've got to look up this and find out more about it. I've got some odd wires. Got this micro switch. This is handy because this one's just got a connector, so that's handy. So I'll keep that one. And then we've got two micro switches in here. And in fact, we could, doesn't matter. See, so that's where that spring went. It went round there, and then it went up at a sort of angle both sides, but it was slightly, like that. And I'm guessing that once that's, yeah, see, that's just held on by a couple of pins. If I can find a way of getting those off, I can use those two switches, or I suppose I could leave them like that and just use the existing wire. Of course, all made in China. But I mean, I never use this stuff for 240 volts, but of course it worked quite happily on low voltage. Make nice little switches. Right. Oh well, while we're here, we might as well have a look at see what's going on with this, mightn't we? So this is the bit that I thought would be spring loaded, and it is. Yep. So there's a little plunger that pops up. And that's presumably quite a good fit so that we don't end up with water coming out. And then what have we got at this end? Well, if nothing else, I'm getting a set of spare screws. Let's have a look. What have we got here? And then that. Oh, look, it just winds in and out. There you go. And so that's effectively like a stopper. And that just winds in and out. And that adjusts our flow rate. So I guess if you wanted to, you could fit this up again to something like a hose in the garden, run the water in here and here, or in there and out there, it doesn't really matter, and then use this to adjust the flow. But I honestly can't really think of occasions when I would want the flow adjusted, so I don't think that's ever going to be much use to me. Is that a stainless steel spring, I wonder? The side of it's not really going to get wet, so maybe it's not. Right, well there you have it. So more screws for the screw pot. So got a fair number of screws left over. I mean, that's just from that one unit. I've got those, and then I've got, you can't see it on camera, I'll go and get it. I've collected all the screws on the side over here. Oh, nearly there. So quite a few screws out of that, look at that. So we got a big pile of screws, we've got a valve that we might or might not use, we've got 3 micro switches, and we've got this which we don't know what it is. And I can't really think of a use for something like that anyway, even if it is some kind of cutout, over temperature cutout. I can't think of any use for it. But I wonder if that's what that is. That gets hot on the top there, and it either closes. Let's have a look. Come on, we'll go to town while we're here. let's put that, we'll put it on 20k resistance, connect these together. Right, so we've got a connection. So have we got a connection across there? Yes, we have. Then what happens if we press that thing up underneath? Oh, we lose the connection. So something happens, perhaps, and it gets hot. By a metallic spring, do you think, inside? Something shrinks up. And then we lose connection. Well, maybe I'll hold on to that then, because maybe I can think of something in the future whereby it would be handy to have something that detected getting hot, especially if, you know, if you can work out what these are, if they do mean temperature. Oh well, we'll hang on for that for now. I always keep these neons, but I don't know why, because I never use them, because I hate the idea, like I keep saying, I hate the idea of anything connected to the mains. So although I've got a little drawer with several of these in it, they never get used for anything, because I really don't like playing around with mains at all, because it's dangerous. Right, I really do think now we've gone as far as we possibly can, so if you're still here and still watching, thanks for watching, and I'll catch you on whatever I do next. Okay, before anyone says I should have tested the elements, it looks like you've got a possibility of a connection there, a connection there, and a connection there, and these are connected together. So this one goes down through the bottom coil up to here. This one goes down through this top coil and up to here, so this one is always common. So it looks like you could put power here to here. And I'm getting what? 12.7 ohms? And then I could put power from here to here, and I'm getting about 12.8 ohms, so pretty much the same thing. Or I could put power to both of them to here, but I could do it in one string. I could go from here all the way through, round, 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 round to here, across, back, round, 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 and back to here. So I go to here, and of course I effectively get twice. I get double what I got before, because I've got two that are about 12.8-ish, so I end up with 24.6-ish. You know, it's not an accurate, perfectly accurate reading, but the thing that's the puzzle, of course, then, is that what was the fault? Because they've both got more or less the same resistance reading. I've got continuity everywhere, so what was the fault? Your guess is as good as mine, unless of course this thing decided that it was going to turn off something because of the temperature. Could one of them have got too hot and this didn't like it? Don't know.